Hey class, this is Mr. Roberts, and question 95 is a great opportunity for us to kind of review all the different ways that we've been developing for solving systems of equations. Remember, a system of equations is a collection of two or more equations with the same variables in them. So there's three methods that we've been using. One of them is called the equal values method. Another method we've been using is substitution. And most recently in our last couple lessons, we've looked at the method called elimination. And it says we can solve these any method that we like to use, but it does say check each solution if possible. So it could be the case that maybe some of these lines don't intersect and there's no solution. So let's go ahead and begin with the first one here. So the equation is 2x plus 3y, and I'm going to write this down and you should do the same. 2x plus 3y, and that equals 9. And the other equation is the opposite of 3x plus 3y, and that equals a negative 6. And I actually moved this down a little bit so the other equations aren't there. So this, I think, is almost a perfect candidate for solving using the elimination method. The only thing that is kind of inhibiting that is if you look at the terms with the y's, right, I've got a positive 3y in the first instance and a positive 3y in the second. If I was to add these equations, right, add equal things to both sides of the first equations, my y's wouldn't eliminate. However, we can modify this pretty quickly by, I think I'm going to choose to modify it by multiplying the second equation. I'm going to multiply both sides of that by the number negative 1. Right? Remember, if things are equal and you multiply both sides of that by an equal value, not only do you get a new true equal statement, but actually the equation you end up with is equivalent to the original equation. All the xy's that worked in the first one would work in this one as well. I don't know why, I just erased all of that. So this was plus 3y. So again, I'm just going to go ahead and rewrite this first equation because it's not changing at all. It just becomes 2x plus 3y, and that will equal 9. However, when I push through a new factor of negative 1 on both the left and right hand side of the second equation, you can see it's going to become a positive 3x and then minus 3y. Again, I'm multiplying both of these terms on the left hand side by a negative 1. And over on the right hand side that becomes a positive 6. So if I combine, and again this always seems kind of mysterious to students, like, really, you're just adding, what are you doing? Look, the thinking is the first equation is a statement that the thing on the left is the same as the thing on the right. And the second equation says also the thing on the left is the same as the thing on the right. So if I add equal things to both sides, I get a new equal equation. So I'm essentially adding 6 to each side of that top equation, but instead of 6 on the left hand side, I'm putting in something that's equivalent to it, 3x minus 3y. That's a lot of talking, but what it looks like is when I combine the left hand side, I get 9 plus the 6 gives me 15 over here. On the other side, I've got my 3y and my negative 3y combine, and I get nothing, so I end up with a 5x on this side. So all of a sudden I know that x has to be the value 3, right? Divide both sides by 5 and we've got x is 3. Now that we know x is 3, it really doesn't matter which equation we pick. We can pick either one to solve for x. I guess I'll just pick the first one. So I'm going to take this first equation and rewrite it, but instead of writing x, the variable, I'm going to put in the value 3, because we just found that x was 3. So this is 2 times 3, and then we'll write plus 3y is 9. So 6 plus 3y equals 9. 3y equals, let's see, 9 minus 6 is 3. And if I divide both sides by 3, I get that y is the value 1. So I think the solution is x is 3, comma, y is 1. There's my solution as an ordered pair. And I can check that by plugging those values into the original equation. And in fact, I'll just use my calculator. So I'm going to say 2 times x, so 2 times 3, and then plus 3 times 1. Did I really need to do the times? Yeah, I don't know why I feel compelled to. Anyways, when I press equal, you can see that that gives me 9, which is exactly what it should have given me, right? So I can see that the left-hand side and the right-hand side are the same. They're both equivalent to 9 when x is 3 and y is 1. Let's do the same thing for the second equation. The second equation says take the opposite of 3. So there's negative 3 times x times 3, and then plus 3 times 1. And when I do that, I get negative 6, which is exactly what I should have gotten. So I can see that the solution point here, x is 3, y is 1, totally works. The solution is x is 3, y is 1. Let's go on to part B. So for B, I'm taking a totally different tact as I look at this. I think this is a good candidate for substitution. And the reason why is if I look at the first equation, it tells me that x is the same as 8 minus 2y. So it turns out that this is a very nice replacement value for x, right? This is equivalent to x. So what I'm going to do is in the second equation where it calls for an x, right, it's minus x, instead of x I'm going to place in that substitution value. I'm going to replace it with 8 minus 2y. So the key here is I'm rewriting the second equation. So I'm going to begin with y, just like above, minus, and now I need x, which is 8 minus 2y. You can see that. So that's y minus x, and this equals 4. Now, this is, I'm subtracting this quantity, right? This 8 minus 2y. So it's really important that I remember that I'm subtracting the entire quantity. So both of those actually will change signs, right? If I want to make it not subtraction, but I can add the opposite. The thing might be helpful is just to take and put a negative 1 here and just realize I'm distributing this negative 1 to each of the terms inside of the parentheses. So if I rewrite this, it becomes y minus 8 and then plus 2y, right? Negative 1 times negative 2y is positive 2y, and that equals 4. So I can rewrite this as 3y minus 8 equals 4. If I add 8 to both sides, we have that 3y equals 12, and dividing by 3 we get that y is 4. So I believe that y is 4, and let's go ahead and plug that in and figure out what x is. The top equation is a great way to find x. It just says, hey, in order to get x, right, what you do is take 8 and you subtract twice y. Well, we just found y was 4. And this becomes 8 minus 8, so x is 0. So let's check this and see if it works. Let me write the answer as an ordered pair. Right, here's my x and then my y. X, y, x is 0, y is 4. And if I plug that into the top equation, let's see, well, yeah, right? If I plug in 0 here, 0 is 8 minus 8, so that's true. And let's check it for the bottom equation. If y is 4, this becomes 4 minus nothing is 4. So totally works. This is the solution. I checked it. It's the point that makes both true. Okay, in part C, as I look at this system of equations, the thing that I'm immediately struck by is the fact that they're both giving me two different ways to write y, right? One way that I can write y is it's negative 1/2 x plus 7, and another way that I can write y is it's x minus 8. So this is a perfect candidate for the equal values method because I know that y is the same as y. And what I do is I'm just setting these two equal things, right? I'm setting y in the first case equal to y in the second case. So if I rewrite this, it becomes negative 1/2 x plus 7, and that equals x minus 8, right? I took the first value of y, and that has to be the same as the second value of y for this system. Well, I guess I would prefer to multiply both sides of this by 2 in order to clear the fractions. Totally an optional step, but I like to use fraction busters wherever I can because I'm not a huge fan of rational expressions. So if I push that factor of 2 through on both sides, 2 times negative 1/2 is going to become negative x, and 2 times 7 is 14. And on the other side I have 2 times x, which is 2x, and 2 times negative 8 is negative 16. And I guess my preference is probably to add an x to each side. You can go the other direction if you want. 14 equals, let's see, 2x plus an additional x is 3x minus 16. And then I could add 16 to each side. 4 and 6 is 10, and that would be 30. So I've got 30 is 3x. And if that's the case, that means that x must equal the number 10. So I see what x is. And again, there's two ways to get what y is up above. And to be honest, if they agree with each other, that's equivalent to checking. So I'm just going to plug in 10 to both of these equations and see if I get the same value. So in the first case, right, I've got negative 1/2 times 10 plus 7, which is negative 5 plus 7, which is plain old 2. So that's what I get from the first equation. And if I plug in x is 10 into the second equation, that's easier, right? 10 minus 8, which is clearly 2. So I can see that regardless of which equation I picked, right, when x is 10, y will be 2 in either one. So the solution as an ordered pair, we would probably write x is 10, y is 2. And then finally, the last part of question 95, part D, there's another system here, and I'm looking at it. They're written in standard form, and in my mind, I think I can easily enough modify it so that they would work well with elimination, the elimination method. And in fact, what I'm thinking is that I'm going to multiply through this second equation. I'm going to multiply both sides of this by negative 2. And the reason why I'm picking negative 2, maybe you can see it already, I'm picking negative 2 because it'll have the effect of making my y's become opposites of each other, right? I'll have a positive 10y and then a negative 10y, so those will eliminate. So let's go ahead and rewrite the first equation again just as it was, right? So this is just 9x plus 10y is the number 14. And the other one is negative 2 times 7 is negative 14x. And then negative 2 times 5y is negative 10y. And over here, this is going to equal positive 6. And if I combine these, 14 and 6 is 20. And over on the other side, I end up with a 0y, right? 10y and negative 10y. But then 9 and minus 14 is a beautiful negative 5. So we've got negative 5x. And then finally, if I divide both sides of that by negative 5, I get that x should be negative 4. We could have made a mistake. I don't know yet. We'll check it in a minute. But let's go ahead and move on. So now that I know what I think x is, let's go ahead and plug that value into one of the two original equations to figure out y. I'm going to go ahead and take the first equation, right? The first equation was 9x, except instead of x, I'm going to place the number negative 4 there. So that's 9 times x plus 10 times y equals 14. This is, what, negative 36 plus 10y equals 14, so we'll add 36 to each side. 10y is 40, 50. And if 10y is 50, then y has to be the number 5. So I believe x is negative 4 as an ordered pair, so I think x is negative 4, and we believe that y is the number 5. And they're asking us again to show a check for this to make sure it's the same. I have been showing you how to do that quickly in your calculator, but a good way to write down that check might look something like this. So I'm going to say, hey, if x equals negative 4 and y equals 5, let's check and see if it works. And it has to work on both equations. So we'll take that top original equation. So I've got 9 times negative 4 plus 10 times 5. And that has to equal the number 14. And I don't know if it is 14, but it has to be that. Of course, 9 times negative 4 is negative 36 plus 50. if I combine negative 36 and 50, I do get positive 14. So because I get 14 on each side of this equation, I can see that it checks with the first equation, but that's not enough. It has to work with the second equation as well, and I can just see that second equation, although my font's getting really small here. So let's check the second equation. The second equation was 7 times what x is, negative 4, plus 5 times what y is, and that's 5. And this has to be the number negative 3. So we're just checking. This is negative 28 plus a 25, and negative 28 and 25 is indeed negative 3. So because that point makes both of these equations true, it makes both the left and the right hand sides equal, and not just the this is the first equation, but also in the second equation, this is the solution point.